Namaste. In this session, we are going to discuss about the chapter Dual Nature of Radiation and Matter. So, the Maxwell equation of electromagnetism and Hertz's experiment on electromagnetic waves were established the wave nature of light. At the end of the 19th century, the experimental investigation on conduction of electricity through a gases at low pressure in a discharge tube led so many historic discoveries. So it has been found that at low pressure, the pressure is of about 0.001 millimeter of mercury column. A discharge took place between the electrodes when they are connected to the when the gases were connected to the battery, and a fluorescent glow will appear opposite to the cathode. So, this fluorescent or this color is mainly due to the nature of the glass. So, here it has been found the yellowish green color for a soda glass. So, the cause of the fluorescent was attributed the radiation which appeared to coming from the cathode. These cathode rays were discovered by William Crookes, and have been said that these rays of cathode rays are negatively charged particles. Then later, the scientist called J.J. Thomson given the conclusion by taking the hypothesis that by applying the perpendicular electric and magnetic field to the discharge tube, he have got the value of speed and specific charge of an cathode rays. From that he have got what? Speed and specific charge, that is E by M, that is electron, charge of an electron by mass. Okay, we have found the speed and specific charge of an cathode rays, and later the American physicists have got the value of charge of an electron. They have said that the charge of an electron is the integral multiple of a elementary of charge of having the value 1.602 into 10 to the power minus 19 coulomb. This is the value of or a charge of an electron, and he have said that charge is a quantized, and with the help of the value of the charge and with the help of the specific charge, we have got the value for the mass of an electron. Okay, this is about the introduction for this dual nature of radiation and matter. And later, so we got the value for the charge of an electron, and with the help of this value and with the help of specific charge, they got the value for mass of an electron. So then how this electron is emitted? So electron emission is how it is taken place. Electron emission. So we all know that metals have negatively charged electrons, or metals have free electrons. This is mainly for the conductivity. So, however, these free electrons are attached to the atoms. So, however, if these free electrons are removed from the or moving away from the metal surface, so if the electrons are moved away from the metal surface, So the metal surface will be having the positive charge, and this positive charge will attract the negative charges, right? So again the electrons will be coming back to the metal surface. So this is due to the strong attractive force of the ion. So we can remove this electron from the metal surface. So how we can remove this electron from the metal surface? By applying energy to the metal or energy to the electrons, we can remove the electrons from the metal surface. So that is what, by applying the minimum energy to the electron to coming out of the metal surface. Okay, that is the minimum energy we need to give to the metal surface to come out of the metal surface. That energy we are taking it as a work function. Okay, work function, that is a minimum energy given to the metal surface to take the electron from the surface is called as a work function, and this is represented by phi, and it is measured in electron volt. Okay, this work function is represented by phi and it is measured in electron volt. So this emission of the electron from the metal surface is taken place in a mainly on the, it can be divided into three processes by the different, they are the three different processes. By that processes, these electrons can be removed from the metal surface. So the names are field emission, thermionic emission, and the third one is photoelectric emission. Okay, field emission, thermionic emission, photoelectric emission. So field emission means what? By applying the suitable field to the metal surface, these electrons can be removed. That one is called as a field emission. So thermionic emission means what? By applying the suitable temperature to the electrons, they are removed. By applying the suitable temperature to the electrons, that can be removed from the metal surface. And the photoelectric emission, this is, photo means light. By applying the suitable frequency of light incident on the metal surface, that electrons are removed from it. That is called as a photoelectric emission. This phenomena is later called as a photoelectric effect. So this is the main emission. Okay, these are the major emission we are considering here. That's a photoelectric emission. So when a light of suitable frequency is incident on a metal surface, the electrons are removed from it. That process is a photoelectric emission. That phenomena is called as a photoelectric effect. So for this photoelectric effect, so many scientists did so many conclusions. So the Hertz also got some observation, and some other scientists also got some observations. Okay. So from that observation, they have said that some metals will emit electrons from its surfaces. If some metals is having the low frequency, they will be emitting the electrons from its surface. And some alkali metals also emits electron from its surfaces. So after the discovery of the electron, these were taken as a photoelectrons, and this process later considered it as a photoelectric effect. Okay. Then later it is considered as a photoelectric effect. Photoelectric effect is a process. Okay. This is a phenomenon of emission of a light from the metal surface when a light of suitable frequency is incident on it. Okay. This is a phenomenon of emission of electron from metal surface when light of suitable frequency is applied on it. The phenomenon of emission of electron from the metal surface when a light of suitable frequency is applied on it. Okay. So later we are going to discuss about the experimental observation of photoelectric effect. Experimental observation of photoelectric effect. Experimental observation of photoelectric effect. So now I am going to draw the diagram for it. Okay. It consisting of one evacuated glass tube. Okay, it consisting of one window, and here it consists of two plates, and that plates were connected to the accumulator. This is quartz window, and this is plate A, this is plate C. This plate is a photosensitive plate. These are electrons. Here from the source, from the monochromatic source, the suitable frequency of light is incident on this plate. Here for the measurement, voltmeter and micrometer and voltmeter were connected. And battery is connected. This is rheostat. This is accumulator. Okay. This is the diagram for the experimental observation of a photoelectric effect. Okay. Here it consisting of a evacuated quartz or a glass tube. Okay. This is one evacuated quartz or a glass tube and photosensitive plate C and the one more metal plate A. Okay. It consisting one evacuated glass or a quartz evacuated tube, and in that it consisting of the photosensitive plate C and the metal plate A. And here a monochromatic source is incident on a photosensitive plate C. This plate is taken as a collector. This is collecting the monochromatic source from the source. Okay. So, and this collected radiations, this will collect and the electrons will be emitted to the metal plate A. Okay. Then it is collected, emitted to the metal plate A. Okay. So, this is the collector and this is the, this is the emitting plate and this is the collecting plate A, and these are collected due to the applying the electric field with the help of the battery, and these were connected to the battery with the help of the potential difference between the collector, this photosensitive plate C and the metal plate A. Okay. And this metal plate A can be made positive or negative. It is depending on the photosensitive plate. Okay. If this metal plate made positive, then the electrons are coming to the metal plate A. This emission of an electron will cause the electric field in the circuit, and from that the potential difference is measured here, and also photoelectric current also measured in the circuit. The photoelectric current which are measured here can be increased or decreased by the potential difference, by applying the potential difference between the photosensitive plate and the metal plate A. Okay, and also the intensity and the frequency of the incident radiation can also be varied by suitable potential difference between the photosensitive plate and the metal plate. Okay, with the help of this experiment, you can able to find, with the help, it is able to find the photoelectric current of the incident radiation and the photoelectric current of a frequency of radiation and the photoelectric current of a potential difference between the photosensitive plate and the metal plate, and also the nature of the material or a nature of the plate used here. So, and later with this experimental observation, it has taken 3 to 4 graphical explanation related to this photoelectric effect. So that one I am going to discuss it on the next session. Okay, thank you.